So did everybody get the location of the preparation instructions? It's also on the Slack channel. There's a Slack channel called workshop-AR, yeah, where the link is. I also have some paper markers for the workshop if you want them. Anyone wants them? Yeah? You? Okay. I don't know what they're for, but yeah, they might be helpful if you don't, if you want to use your. Oh, you already have one. Okay. Okay. So if everybody got the address, I'll just go through this. So the idea is that you get the repository, then you download, you pull the image, which takes a while, as I can see, and then you make sure that everything is fine by building using this image and then running the server. Then you should see something like this, and there are a few links where to go if you want to see this or that. And then you can open this AR marker or just use the paper one that I got you. And you also, like using your phone, if it's on the same network as your laptop is, the address here should be theoretically picked up automatically. And if you go by, say, this address, you can see the VR version of this, or if you go by this well, this the actual IP address may vary for your specific computer, obviously. But if you go there, then you should be able to see like a web page, and if you allow it to access your camera, then you would be able to like see with your camera, and then if you like take this marker, and if you point it, then you should see a Lambda logo on the marker. Okay. So that's basically the test that everything works fine, and you are ready to proceed with the workshop. Okay. So who has everything set up already? Okay. So still the two people. Okay. So what's the progress on the downloading of the image? Is it like 1% or 50%? Sorry? About 50%. So if I just talk for about 10-15 minutes, it should be okay, right? Great. So let's do that. Then. So these are the preparation instructions. But yeah, we'll have to wait another 10-15 minutes until that. Until then, and I will then. Sorry for the flickering, because. Yeah, I will just quickly show the environment that I'm using, like how I'm working with the code. So here I am. Yep. Yeah. So here I am in the terminal, and I actually have like 4 terminals on one screen. So on the left I have a Vim, but you can obviously use your favorite editor. And on the right I have 3 terminals to run several commands in parallel, but we'll see about that. So let's first concentrate on the structure of the project. So the idea of this workshop is somehow to be able to construct a working multiplayer game in augmented reality in Haskell in 2 hours. Well, for you to do that in under 2 hours, I have already everything set up, but I spent obviously more than 2 hours. Here on the left, you can see the directory structure of the project. And there are some files, but the code that you're interested in is located in the project directory. And there we have a stack project, actually 2 stack projects. So how this whole AR thing is going to work is, well, because I could not have predicted which devices you would bring with you. The only thing I could rely really on is on web-based technology. So there actually happens to exist a virtual reality framework in JavaScript, and also an augmented reality library for JavaScript. And there also happens to be a compiler from Haskell to JavaScript, right? So the idea was basically to connect all the multiple pieces of technologies. So write a server in Haskell with just GHC, and to write the client side with GHC.js connected to these JavaScript libraries, somehow make it all not break, and in the end to have this playable game in augmented reality. Okay, so that's why we have this two stack projects. You can see stack YAML and stack GHC.js YAML. Now, if you are interested, I can talk about those later. But for the workshop, you're actually only interested in the code, and running the builds. So the code is split into 3 packages. So the project itself is called ARCube, because that's somewhat what's the game that we're going to build about. It's about a cube. And it has ARCube, which is the common package that is used by both server and client. There is ARCube server, which is the server part, and ARCube client, which is purely the client part. Okay? Okay. So in the ARCube project, you can see there are a lot of source files. But most of them are like utility file. There are some utility files. There are some redirection files. What you're interested in is these stage files. So stage 0 is what's working by default. So if you just pull the repository, this is what's used for the heart of your application. You don't have to go into any other module so far. You can just work here. Okay. Now, stage 0 doesn't have any exercises in it. It's just the for the test that your setup is working correctly. Okay. Now, there are also stage 1, 2, 3, 4, 5, which do contain exercises that you're encouraged to do to make your application a bit more interesting than just a logo. Okay. In case you have any trouble with the exercises, there are also solution files. They're located in game solution stage 1 and through 5. So you can peek into those, but I really recommend to just try and work the exercises yourself before peeking at the solutions. Finally, the only other module you would want to touch, apart from these stage files, is this game.hs, which is basically a way to select which stage to use for the build. So right now it says stage 0. I can change that to stage 1, and it will then use stage 1 for the application. Okay? Great. Now let's get back to stage 0, and I will explain to you a little bit about how I, at least what is the workflow that I incorporated while working on this project. So obviously, you could just build everything and try out on your mobile phone with an actual marker. But that tends to be a little bit cumbersome because you have to connect your phone to your laptop, and you have to operate multiple devices at the same time. This is sometimes not something you would want to do. It's one thing. And the other thing is that you might have some problems in AR, well, you have to use like markers or some stuff, and it might not work, or it might cause some troubles, or you just don't want to use your phone. And in that case, it actually helps to go to the VR version of this project. And so this repository is set up in such a way that it uses your code to build both the VR and AR. So VR stands for virtual reality and AR for augmented reality. So VR is easier to test, easier to work with. So you would naturally first start working with that. Another thing is that you probably want the sources to be recompiled every time you change something and not like run multiple comments on your own. So for that, there are scripts. So there is a with Docker as a sh script. And if you run it without any arguments, it will tell you which commands it supports. If you have already downloaded and tested your setup, you'll have already run it with build and run. So build basically just builds everything, and run runs the server. But there are, for development purposes, there are some other things. And first of all, it's build watch client, which I will run in this window right here. So what it will do, it will build the client. I have it already built, so it says success, and if you want to rebuild it, you just press enter. Okay, and in this window below, I will do the same, but with the build of the server. So this one will rebuild the server and launch it so that I can visit it. Now, it tries to guess the IP address you can use on your phone, but I found out that for some Wi-Fi networks, it doesn't work. So what I found always works is if I connect my laptop to the network, to a personal hotspot from the phone, okay, or the other way around. Okay. So, there is also this localhost address, and the address for the marker that is also served in case you don't want to use the paper one. Okay, so if I go now there to this page, so I will see this virtual environment, which I can traverse. I can actually walk here, and I will see this this object here, and I can play with it. There's a cursor, so I can imitate touches and everything else. Okay? Make sense? Any questions? How's the progress on the downloading? Nice. Nice. Okay, right?
Does anybody else need any help getting set up in any way? Because they can help create, and I also have data.
On the phone? Okay, so for that.
Stack setup or the project setup? Can I yeah.
So if you cannot connect from your phone to the laptop, try setting a hotspot on your phone and connect.
That's what I just set up.
Okay, okay. Okay, you can do it also the other way around. If you know how to set up a hotspot on your laptop, you can do the other way around. But I think in that way, you might lose the internet connection. So I prefer to connect to the phone. Okay, so that's basically it. So I'm sorry. So we have this dark environment where we develop our code. And then when we're ready to play with the intermediate result, we go to the browser, we can refresh it, and work with it. If we want to, we also can invoke the a console and see if there are any problems. Now, this problem is not a problem. But yeah, we can see logs, we can debug this stuff. Another interesting thing that I'm not sure if we are going to be using it in this workshop, but for development purposes, there is So in this virtual reality framework is actually embedded an inspector that you can use to see which entities you have You can play around with them, you can move them, and you can see what actual position or rotation they have. So you can actually interactively play with these virtual objects to see which properties you want them to have for the scene to look as you wish to, and then apply that to your code. Okay, so sometimes this is really helpful if you have some complicated scene. I don't think we're going to be having that in this workshop, but it is a useful feature to debug these virtual environments.
How do you bring that up?
So I think it's Control Option I or Control Alt I. So it's an inspector, I for inspector. Now, yeah. And so just to be clear where to look for, so what we're using here is a JavaScript framework called A-Frame. So just a few words on how it works. So it's a JavaScript framework, but it actually relies a lot on the HTML layout for the scene. So it actually tries to be declarative. It's obviously not Haskell, it's HTML. But it so happens that in Haskell, we have libraries that are similar to things like Elm, or if you're familiar with this language, that can actually, if you're not familiar with Haskell that much, maybe you've heard of things like React.js. So Haskell has something similar and probably better. But the idea is that you have this declarative way to specify the view, and we're going to be relying on that a lot. Okay? So again, let me just go to the code and explain what's happening here. So we have this very simple architecture where we have a model, which in this case is called game. And right now, it's just a unit type. It doesn't have anything in it. But we will be adding stuff to it. We have also game action, which is a type of events that might happen inside our game. Okay? There's obviously an init game, which initializes the game. Handle game, which takes a game action and processes it, so updates our model, and render game. So render game here is actually the thing that generates the HTML. Okay, so based on our current state of the model, we're going to generate different HTML files, HTML contents. Okay, so whenever our model changes, the HTML will change, and A-Frame will pick up on that, and our environment will change. Okay, that's the basic idea of how this works. Everything else, how server works and how client works, for now, just forget about it. All you have to work with is the pure logic of Haskell. You can see that we are not having any IOs here. Everything is pure. Okay, and that is actually very beautiful. So I think I've talked through the setup. Another thing that you might want to use is that's what the topmost, rightmost window is for, is the REPL. So you can invoke that with Docker REPL, and that will actually load the common and server part. It will not load the client part because, well, yeah, those are some warnings. So the REPL mostly is useful for the common part to just work with the logic that you have. And you can have things like, if you want to know what's the render game of init game is, I'm sorry. Yeah, I have to first, because I have a lot of games defined in different stage files, I have to specify which stage file I want to work with. So I'm going to do :m for go to specific module, and I go to ARCube game, say stage 1. Sorry, stage 1 is not implemented yet. It's an exercise, right? So I go to stage 0, and if I want to know what will the initial game be rendered to, I can just call render game of init game. Yeah, and that will be a lot of HTML because it's like it's Haskell logo composed of many voxels. But you can see that, well, that's that. Okay. Good so far? All right.
Can I ask a quick question? Where
Yeah.
does view come from?
Sorry?
View at the bottom, you have the view type. It's below that.
Oh, the view type. Okay, so for the view, we're relying on a Haskell Haskell library called Miso, which is basically the Elm architecture implementation in Haskell. So if you are not familiar with JHTJS scene in Haskell, there are basically two libraries that are somewhat popular for front-end development in Haskell, and yes, that is a thing. One is Reflex DOM, but it involves FRP, which stands for Functional Reactive Programming, and which is by some people described as Haskell within Haskell. So you have to be like extra smart to do that. So I prefer dealing with simpler approach, which is Miso, which is based on Elm architecture, and it seems to be working pretty good so far. Okay. So view here is basically the this DOM virtual DOM thing. Okay. And it's a list of views because it's easier to work with a list of views rather than individual views. We'll see about that. Okay, so stage 1. So I will go through stage. Does anybody has any questions before I go into the first exercise? How many of you have successfully set up the environment? Can you again raise your hand? It's 5 people. Okay. Okay. So so these stage files with exercises are set up in such a way that they compile by default, but they have this _exercise thing defined in the module, which if you delete it or if you comment it, just comment it out, then let me just reload in the repo. So what I see is some errors. It tells me found the whole _exercise. And it tells me that it's on the 51st line. So I go there. Indeed, I have this exercise. I have to implement this function cube 3x3. And it actually tells me what is the type of this whole. So in this particular case, we know that immediately know the type. But in other exercises, this thing will be used inside of some expression. So it would be helpful for the compiler to tell us what type is expected there. Okay? And in fact, if you've been programming in Haskell or similar language, you might know that programming with typed holes is actually very advantageous in that you can jump into some unknown code, and the compiler will help you out by giving you more context than you can see in the code. Okay? So you can see here that there are a few more things defined compared to stage 0. So let's first read. So the exercise is to render a 3x3 cube using cells. So cell is something that already is defined, which is, well, we can read here, it's a box with an orange color and which is translucent, right? And it's also scaled a little bit. Now, what we are supposed to do is to implement a 3x3x3. Actually, it should be 3x3x3, sorry. I forgot that we are in 3D. And render game is actually using cube 3x3 it just scales it a little bit and rotates it a little bit. Now, if you've been working with any like functional graphic library, like maybe I don't know, Gloss for 2D, you may be familiar with this approach when you define some image and then you manipulate it and then you bring them together. So this is the approach that we're going to be taking here. Although this is not exactly the approach that I've seen most of these A-frame applications in JavaScript do, although A-frame actually supports this feature. OK, so first thing that we can do, so since we only have this one exercise, we can just use cell here directly, which is already something. And so what will happen now is the client part will rebuild and the server part. The server part is actually irrelevant for us. It just builds a little bit faster because GHC works for some reason faster than GHC.js. And so we can actually, if there is some error, we can immediately see it there. OK? So so once it builds the common library, it rebuilds the client library, and then it copies over all the compiled JavaScript files into a necessary location so that the server can pick them up and we can just reload the page. OK? OK, so everything is fine. And we can now go to the virtual environment, and we can update it. Yeah, can we? Oh, and it, of course, shows us Lambda because we did not update the stage that we're using. So I'm going to go to game and change that to now use stage 1. OK. So and after it rebuilds the stuff, which unfortunately takes a while. So a faster approach might be to use an interpreter, a JavaScript interpreter, and to reload and run from there. But unfortunately, interpreter only works with a very ancient version of GHC 7.10. Yeah. Well, the version of GHC that's used here is also somewhat ancient. It's 8.0.1. There are actually working versions that are fresher. Actually, I hear you can have 8.6. So here is the cube. OK? So what happens here is, so this is a cell. So how did this happen? Let's walk through the code again. So a cell is just a box of orange color and which is translucent, and it's scaled a little bit. So by default, box is 1 by 1 by 1, and we scale it to be a little bit smaller so that there is some space between the boxes in the future. And then we scale it even further for reasons. And we rotate it a little bit. And that's exactly what we see here. So it's a little bit rotated. So rotated and scaled and box and even prop are defined in utils. There's utils A-frame, which defines some helpers for rotation, translation, and scaling, and also animation. But it is actually very, very simple. So let me show you for comparison what it looks like in the actual A-frame examples. So here you can see there is a scene, and you can have a box that has this position, which is perfectly typed, this rotation, and this color. OK? So, Yeah. So what I do is in these helpers, you can actually see that. So let's go to the interpreter and go to reloaded with the new code, and go to module AR cube game stage 1. It's now right, and we can now render init game. And you can see how this works actually. So yeah, probably let me just make it like this. So you can see there is a box of color orange and opacity 0.5, and that matches exactly this thing here. So when we apply scaled here, what we do is we wrap this box in another entity, which only adds the scale. Then when we render the game, we also scale it even further by 0.3, 0.3, 0.3. So there is another wrapper entity. And when we rotate, there is another wrapper entity. OK? So it actually gets translated pretty much directly into the HTML. OK? Any questions? OK. Yeah.
I got here, like, so this question, a framework I understand works on it with the HTML, and there is some library from Haskell that you use to between those two, like.
So so we're using this MISO library.
Okay.
That allows us to just so we have this render game, which is a renderer for the current game state. So we have a game state, and we translate it into this list of views, which is basically a HTML. Okay, and so these helpers, they are defined in the utils A-frame, and they are very straightforward. Like I could actually write this box as like node HTML a box with these properties, and then with nothing as the content. It's just
The only thing that I'm missing right now is that on the right-hand side, I see HTML, so I can understand there's like a show type class.
yeah. So the show type class for view actually renders HTML.
Okay.
Yes.
Good to go. Thank you very much.
Okay. So now the exercise is actually to render a 3x3x3 cube, which we can do easily by using the power of Haskell, right? So how would you do that? Sorry? Repeat? What do you mean repeat? Well, we use cell, but we have to place these, how many cells? 27 cells, right? At different places. So how would you do that? Yeah. So what I would start with is, so I would do a least comprehension, because I want to iterate all the x coordinates, the y coordinates, and all the z coordinates. I know they are going to be -1, 0, and 1, and I can scale it whenever I want to. So I can just go with the simple units. So I will have this I going from -1 to 1. I will have j going from -1 to 1. I'll have k going to, I just use this for integer coordinates. Okay? So now what I have is I, j, k are the coordinates that I want to put a specific cell at. So I actually want to draw a cell, but I want it translated to x, y, z, which have to be float. And actually, I can just use I, j, k, because I didn't specify that these are integers. OK? Do I have to do anything else? Yeah, so I have to concatenate this, actually, because, OK, so we'll see if I do not put anything here, and I reload it. So the problem is that the result, it has extra list wrapped around it. That's because all these things return list of view. So I have list of view, and I can ask what type I should apply to this to get a function of which type I have to apply this here. And it tells me I have to specify a function that takes a list of lists of something and return a list of something. So this is exactly concat function. So if I now reload it, it's perfectly fine. And I can, again, render this. But it has now like 27 of these things. So it's barely readable here. OK. Now I can force rebuilding of the client. And when it builds, hopefully, I will get a 3 by 3 by 3 cube. Any questions about Haskell, about the setup, about the project layout?
For Haskell, do you need that type hole kind of thingy? Is that kind of extension needed, or just
Which one?
like you did this hole and the compiler helped you out? Like
No, this is a feature of the compiler.
it's already built in.
Yeah, I from some version, and I think it's from like 7 point something, so it's pretty old. I think in 8.8 it's gonna also provide some smart suggestions as to what you can put there. So okay, so it has been rebuilt, so we can now visit this virtual environment, just reload it, and we have a 3 by 3 by 3 cube. Okay. Yeah. 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 So this A-frame framework takes all the handling of the virtual environment for me. Yeah.
So I was just wondering, where are you using resource coding?
For what?
Because you're only generating HTML, are you creating HTML or?
Yeah.
So where are you using resource coding? The framework?
The framework?
Yeah.
So the framework basically handles the updates. So right now we don't have any updates to the model, right? We don't have any actions. We have only a static HTML, right? But like in the next stage, I think we're gonna introduce something else, and then yeah, that's good. Okay. Okay. So who still did not download and set up this thing? 4 people? 5 people? Everyone else has this set up. Does it work for you? Do you have problems with the smartphone? No? Okay, good. Okay, so let's see what's the next exercise. Now, right. So the next exercise is going to introduce a little bit of interactivity. So what happens here is I have already updated the model. So the model now has this list of coordinates, and it will actually represent those cells that we have, say, activated, okay, or marked as it's called here. And we have a single possible action here, which is set mark for some coordinates. So if this action happens, we now know that this cell is marked. Okay. We have these coords is just 3 integers. Init game is now initialized with an empty list, so all cells are unmarked. And we have this handle game, which now has to handle this case. Okay. So the only possible action here is set mark. So we set mark coords, and we have some state of the game where we have a list of marked coordinates. So it should be very easy to implement what should happen here if we want to mark another thing, right? So that's one thing. Now, cube 3 by 3 now has this marked as an argument, so we can render it properly, render marked cells properly. Here, the implementation changed a little bit. Now we have this X, Y, Z, which are just explicit conversions from integer to float, which is necessary for translated. And cell now also takes 2 arguments. So before it was without the arguments. Now it takes as argument is marked, which you have to define, but should be very straightforward to do, right? And coordinates of the cell. So let's see why we need these coordinates. So the implementation is basically the same. The only thing that is changing is that the color now should depend on whether the cell is marked or not. And we also have to introduce some way of knowing whether user marked something or not. And the very natural way of doing that is to use the onClick event. So whenever user clicks on an object, which again, the A-frame framework handles all this virtual environment stuff for us, we can just use this onClick event to hook it up to a specific action that we want to happen to our model. So I will show you this part because it's, well, it's non-trivial because it requires you to go to the documentation of Miso, but it's actually very straightforward. But yeah, because of this jump, I will just show you how it's done. So there's this onClick thing that just accepts any action that we want to put here. So, and let me just roll with this. So this is going to be onClick action. And again, if we reload, the compiler should tell us that this whole underscore action actually has type game action. So this is actually pretty cool because we can hook up an event that we defined in Haskell to a to event that happens within HTML DOM. Okay. So the rest is simple. So action here is it can only be setMark. We don't have any other actions, right? But setMark has to specify which coordinates we want to mark, and that's why we pass these coordinates to cell in the first place. So when we render the cell, we also say that if this specific cell is clicked on, then we want to mark it. Okay. So do you want to take a minute to try this out yourselves? Any questions, any problems I can help with? Yeah, because translated works. So let's just go to the interpreter and ask what is the type of translated. So sorry. Yeah, I have to specify the utils A-frame, right? So the type of translated is float, right? But I want to deal, in my model, I want to deal obviously with integer coordinates because it doesn't make sense to work with floats in my model. Okay. So I have to translate between the two.
Okay. Also, those utility functions, is it something that you wrote?
Sorry?
This is something that you wrote, those utility functions?
Translated, yes. So translated works very So you can actually, yeah. So there's this, so box is also something that I wrote, but it is very simple. Like you could literally do it with meso primitives, like import meso node HTML. It's called a box. It doesn't have any attributes or any contents. Yeah, and I have to enable this overloaded strings. But if you go, there it is. And that is basically how box is defined, except it's passing down the arguments that I specified to it. So if I have, now I can show you how the translated works. So I can translate it like 1, 2, 3 of the box. What it does, it wraps the box into an entity tag that has this component position that is basically relative positioning for the contents. Okay. Any questions? Okay, so just let me go again to the game, and I will just use game solution stage 1. I will not show you the code because it's very straightforward. So yeah, you should be able to do that on your own. Sorry? Oh, stage 2, right. Thank you. Yeah, so I just want you to show you what it should look like when you have it working. Oh, it doesn't work. Why is that? Because I don't have instance read for game, because I forgot to add because I forgot to add it to the solution file. Yeah, I added to the okay. It's gonna be read here and read here. Yeah. So the show and read things, show is obviously useful for debugging, but when you want to look at the stuff in the interpreter. And read is actually used as a sort of easy to use way to communicate between client and the server. We're not using that communication so far, but it still needs it to compile with it. Okay. So if we update this now, did I update it? Yeah. So now what I can do is I can point and click, and they will turn red. So I can go around, yeah, click this one. So I can do this, okay? And in theory, if you open the same thing in augmented reality with your smartphone, you should be able to tap on the cell, and it should theoretically be marked. However, it doesn't work perfectly, at least not on my phone. For some reason, the cursor sometimes gets moved around. I'm not sure what the case is, but what the problem is, but it seems to be not the problem with my setup or anything, but with just the support for my device or something. So I can't do much about that. Hopefully it will like become better. So yeah, I still was able to like click on the things. It just was not that predictable. Okay.
What happens if there's a runtime error?
Runtime error where oh, then you have a runtime error in your JavaScript, right? Because you compile to JavaScript. So, and then turns into an exception that you can see in the console. Okay. Now, sometimes you get a good error. If you use error specifically, you should be able to see that specific message. However, if there is some other problem with the runtime, then it might be like not that easy to determine what's going on. Okay. Good. Now, what I want to do, so what the idea of this project, of this game is to do a tic-tac-toe game on a 3x3x3 cube. I think I don't actually think about the central piece because it's not visible from here. But it's on this cube, and the extra thing that is interesting is I want this to be a Rubik's Cube. So players can either mark, so let's say they have like X and O, or they can have blue and red marks. And on their turn, they can either set a mark or rotate one of the slices of the cube. Okay? So I thought this would be like an interesting game to play in 3D. So far, we have this means to mark something, right? So the other stages build toward the final game, where there are two players, they take turns, and they can either mark or rotate a slice. Okay. Some of the code for especially for the rotating of the slices, is already there. The interesting part there is the animation, how you do animation. Okay. So, any questions so far? Okay, good. So now let me go to stage 3. I'll also build the solution. Stage 3. I will probably have the same problem, but I will fix that. Okay, so in stage 3, we now introduce a focus. So this is a very simple addition to the previous stage. But now we actually, so before we had just wrapper types for both the model and the action. We had only one possible action and only one field for the model. Now we will have 3 different actions and 2 fields in our model. So we have the same marked cells, but we now also have an optional focused cell. So whenever we just point at something, it becomes focused, and if we then click on it, it becomes marked. So this should help keep track of who is trying to mark what part of the cube. So, and the actions are set focus and reset focus. And the implementation again is, so no new functionality is introduced here except for 2 new events, on mouse center and on mouse leave. So one is for set focus, another one is for reset focus. Okay. So this one is pretty straightforward. Let me just quickly fix this thing and show it to you how it works. I already changed that. Yeah. That's why the error was there. Yeah. So unfortunately, the rebuild cycle is not that fast, as you can see. So that's why I'm saying that if there was a REPL available for the fresh versions of JCJS, that would be way faster. Okay, so what we have now is so we have this pointer, this cursor that is able to track what cell we're currently looking at, and we can mark it red permanently. Okay, so this is basically it. In terms of the code, this is a very simple addition. So I will now go straight to, let me again go and change this to stage 4. And let me see if I have to update this. No, it already has everything set up. So stage 4 has a few additions. So in addition to marked cells and focused cells, we now have slice rotation and rotation count. So a slice rotation is if a player chooses to rotate a slice, then we remember here which slice was rotated last. If the last action was not a rotation and was instead a marking event, then we will have nothing there. Okay, so we store this in the model to animate rotation, to know if we have to animate rotation or not. Okay, and rotation count is actually something to tell a frame that we have to animate rotation even if the model didn't change. Now actions again are the same plus rotate slice here. So and rotate slice is again there is a maybe of, I don't remember why, but nevertheless. I mean, I don't remember why it's a maybe. I think we could have made it just slice rotation. So a slice rotation itself is a data type that tells you around which axis to rotate and which of the slices along that axis we should rotate. So rotation is just by how much we want to rotate. Initialization is fairly straightforward. Now handle game is interesting. So here, where we handle set mark, so to not just complicate things too much, what I do here is I want to rotate a slice if a player clicks on a cell that is already marked. So I somehow choose which slice he means, and he's able to do that. So this is like complication in terms of rules of the game, but it's a simplification in terms of implementation, because otherwise we would need to somehow introduce more objects into our scene so that the person would be able to specify which direction and which slice they want to rotate. Now, ideally, what I would want to use here is just a swipe. So if I would just use a swipe along a few cells, then I might, in theory, be able to understand what is the user's intent. But I did not find a way to do that, at least not without a ton of JavaScript. So I settled for this a simpler implementation instead. Okay. Now let me see. So here are some helper functions that you can use to rotate your model. That rotate in the necessary direction, in the needed direction. And the nice part is this animate rotation. So now in addition to translating the cell to an insert position, we also apply some animation. Now, see that we apply animation to individual cells and not to the whole cube or something. So we want to rotate some cells. So we need to pick cells that are involved in a specific slice of the cube and apply animation only to those. Yeah. So I think it's defined here, right? So what this has here is if we have a rotation, then this is your exercise, add the animation. And below you have animation for the cells that should not rotate anywhere. So how animation works is, again, you apply this component to an HTML element, basically, to an entity on your scene. And if you just introduced it, this animation, it basically starts the animation process. And then if you remove it, then you no longer have the animation. So in this animation, it only works once. So if this specific entity did not change this animation property, then it will not reanimate if you update some other part of the scene. So that is why we're using this counter here to work around this. So we add this animation 1, animation 2, animation 3, just in case we want to rotate the same cell in the same direction, so it works every time. Okay? And so rotated animation is, again, a very simple thing. Let me just so have rotated animation, let's say 1, from 0, 0, 0 to, say, 36, 0, and we want to apply it to, say, a box. Now, what happens here is, again, we're just wrapping a box into another entity that has this animation property, animation component that itself has some properties. So we tell it that the animation is animating the rotation property of the cube, that it goes from 0, 0, 0 to this. So these are angles. It also says that the duration of, yeah, I think it has like a typo there. I'm not sure how it works actually, because it does work. But so it tells it that it should last for a second, and what is the type of the animation we want to use. So there are a bunch of different options you can choose from, which is like very useful when you're doing this. There are a lot of animations available in the A-frame. There are a lot of animations available in third-party JavaScript libraries. So you can just choose any of those, wrap it very easily in Haskell with better types, basically, and use it in your application. But again, the key point here is that animation is just basically a property that you apply to an HTML node. Okay, so you're not doing this like in the model. You're not doing this animation in Haskell. You're using this readily available animation from A-frame. Now let me show you how it works. So basically, if you, I'm sorry, did I update it? I don't think I have the stage 4. I think so. Oh, it did not rebuild, sorry. It's yeah, it can be compiled to both server and client side. Yes, so it's the common part. So I think the for the stage 4 is the last interesting part regarding the thing. So here, if I click, it rotates. If I click on this, it rotates this way, and I can rotate it that way and this way. So the corners do not rotate because I don't know which direction to rotate them to. Yeah. So you could actually imagine having like extra, I know, spheres or something that would be that you would be able to click to rotate in the necessary direction. Or, as I said before, ideally you would swipe things in the way you want to rotate in that way. So this is how the rotation works. So in stage 5, the last stage is introducing the players. So it actually doesn't introduce any more in terms of the virtual environment. It just introduces the player, distinguishes them, which player is the current, and if you just load that again in the virtual environment, you would be just playing with yourself or, you know, hot seat. Let me quickly show you what that looks like, and then I will explain how the client server thing works. Okay.
So I'm curious, Miso is running on your shared code, right? It's not on the server or on the client.
It can run on both.
Is it running on both?
So for now, what I'm showing to you is running on the client side only. So you can just use that basically static HTML and JavaScript. The server is only used to serve this over, I don't remember. There are some problems when you just open an HTML file. You have to run server, I think, for some things. At least there is no easy workaround. But yeah, for now, we're just serving static files. And in a second, I will show you how you actually can do the computations on the server and then render them on the client.
So you can have multiplayer.
Yeah, sure. So now it has somehow 2 foci, I guess. But yeah, you can do it like this. Oh, this is just marked already. Okay, so the second player marks, then this player marks, then I can rotate this stuff. Then again, this player works, and I can rotate this stuff, and so on and so forth. Okay? So that's basically the game, and now whoever gets like 3 in a row wins, and so on and so forth. So the interesting part is now the client-server communication. So let me show you that. So here I will leave the stage 5 thing. And the only thing that I'm going to change, so I'm going to show you first the client side. So the client has actually some code in it. So there is a wrapper around our model, which has this Miso application running. And it basically has its own model, which is either it's loading or it has the game. So right now, the model for the application is very simple. And there are actions. So actions here are no operation, start game, and whatever happens in the game. Now, this one happens at the start. So we basically, this is just the initialization of the application. But you can see how this works, right? So there are also some update model, but they are, again, straightforward. They translate to our game model and game view. The only thing here that is probably interesting is that when we render game, we render it in either AR scene or a VR scene, depending on the mode that we've chosen. So these AR and VR scenes are again defined somewhere in the utils files, but again, it is just a simple HTML wrapper that has some cursors set up, and like for AR, it includes AR.js component and so on and so forth. Now, so this is very straightforward. And we also have this client HS, which is very similar, but it involves the connection with the server. So how this works is you can see it connects via WebSocket to a server at /connect something. And whenever it receives a message from the server, it actually tries to parse it. And if it successfully parses it, it puts it into a queue, okay, that the other process here is trying to read in an infinite loop. And whenever it reads this loop, it issues an action called sync. And you can find it here in actions. So we added sync game, and what this does basically is it waits, it listens on the WebSocket for any updates to the game model from the server, and whenever it gets one, it just applies it directly to its client model. Okay. Now it has both the in-game action and sync. So it actually, this client is actually applying the game action that happens with the user, like before, but so it's like a, you can call it a predictive client, right? So you can interact with your environment locally, and then whenever there is an update from the server, it just synchronizes in case there were any mistakes locally. Okay. Okay. So other than that, this thing is pretty straightforward. So there is obviously some code for the WebSocket connection, but it is all like wrapper. It is not that essential to the development of the application. This is the standard thing that you would do. You might, of course, change like the way you represent data that you send through the WebSocket, but logically, this is a very simple thing. Okay, any questions? Okay. Now, there are actually two client applications. So one is called AR, client AR, and another is VR. And you can see there are two mains here, and it just runs VR, or here it runs AR. And this is just to make two separate JavaScript files, so I can, when I develop, I can choose whatever I want to test with. Okay, but right now you can see that it uses ARCube standalone, and standalone client doesn't communicate with the server. It just handles all the updates locally. So if we just change that to ARCube client, so for AR, and let's change that for VR too. Let me rebuild that. So while it's rebuilding the client to communicate with the server, let me quickly go to how the server is actually implemented. So, right. So the server that we are connecting to right now is a very primitive server that doesn't know anything about players. So the only thing it does, you can see here, where in it. So it has some configuration, runtime configuration, which keep tracks of the current game state, the previous game state, which it needs to know whether or not to send updates to clients. A list of clients, and every client is actually just a WebSocket connection. And here we just have an infinite supply of player names to assign to connecting clients. Okay. So what it does, basically, the idea here is that it just has this model internally. And whenever a player connects, the player can communicate with this model by sending actions through the WebSocket. So again, there are a few lines of code here, but the idea is, again, very straightforward. This is the code that you would write for any server that communicates this way with the client. It does not depend on the actual application that you're writing. Well, so far. Okay. So now if we go to the same VR thing. Yeah. So what I will do now is, because we are interested in client-server stuff, I'm gonna actually go and create another window with the same client, and then I'm gonna do it like this, so that I have two clients on the same window. Okay. Now, yeah. Does it work? Did I do it correctly? Oh, connect. Okay, so it cannot. So the I don't know if you see, but there is an error with the WebSocket because it cannot read the thing from the WebSocket for some reason correctly. And I'm guessing that is because I'm not using the correct, yeah. Let me go to server main and import this server. Let's call server stage 5. Okay. Oh, there is some error. There was some error on the server side. Maybe there are some differences with this. So this server stage 5, let me just show you what is different about that. So the difference is that in the server stage 5, we actually keep track of which client plays for which player. And what we do here is we assign the first client who connected the first player, and the second client to the second player. And everyone else is considered just a spectator, so they can look at what's going on, but they cannot interact. So let me try this one. Yeah. So this one appears to be working. So the left client, yeah, there is some lags. I'm not sure why, but maybe because I'm doing a lot of things on this laptop. Sorry. I think let me reload the pages. Oh, now they won't be able to interact with it. Oh, no. This one. I think they are disconnected. Yeah, they cannot communicate with the server. I'm not sure what's going on because it worked. So the error is blah blah blah. Stage 5. So it's in the common code line 16. So let's see what's wrong with this line. Oh, it's actually it's stage 5. Exercise in stage 5 is not implemented. Okay, sorry. Yeah.
That might be the reason.
Yeah, that is exactly the reason. But yeah, where is the server? That is because it should use actually solution stage 5. Let's reload the server. So as you can see, there are a lot of interconnected things. So yeah, it would be nice if it would be able, if you would be able to somehow compress this into a single file that just works. But I have no idea if that's even possible. So this is the minimum setup that I was able to build that demonstrates all the stuff and is actually working. Well, we'll see if it's actually working, right? So we reload this one, we reload this one. Okay. So you can see that we are focusing different cells on the left, and they are immediately focused on the right side. Now it's this player's turn, so okay. Now you can see that it rotated on the right but did not rotate on the left, and that is because we have the handling of actions on both client and server, as I said before. So the client will actually try to interpret all actions you are trying to do, like as you're playing for both players. But the server then tells you, no, 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 you cannot. Your action does not count. So it reverts to the other state. Okay. So we can actually disable that in the code, and so we can rotate this thing here, and we can see that it rotates on both. So basically you can see that it is working, right?
Can you connect that from your phone?
From my phone. I should be able to. So what do I have? Yeah, I have it connected to my phone. So if I just go to I'm not sure if I can show you this. Oh, I have to reload the server so that I can connect as an actual player. So let me do that. So I will just make the left one. Then on the phone, I do. I don't think I'm able to connect for some reason. Can I do at least? You can try that. Yeah, for some reason I cannot connect. Maybe because I was not using this for some time. Let me see. There are lots of handshake failed errors. I think those are coming from my phone. I'm not sure what the problem there is actually, because the address seems to be correct. Let me just reload Safari on the. No, there is another. Yeah, so it's definitely coming from the phone, but it worked before.
Could it be that the client is a little bit different than what you wrote here? That there's like a difference?
No, I'm trying to connect to the same server, to the same code.
Well, but you have a client. Where does the phone get the client code?
So it goes to the server that serves as static files the client, and the same client also talks to the stream. Yeah.
You're using Safari. Are you dependent on Safari? Does A-frame work better in Safari?
No, I think it works worse in Safari, but that's what I'm stuck with. What I can maybe show you is if here I launch, let me try this. So I will show, yeah.
I have another question. So can a VR and an AR client, yeah, I guess they both connect at the same time, right?
Yeah, I'm not sure why it's stuck there, but let me try doing like this. Yeah, like it should work, but for some reason my computer is not feeling very good. Maybe because I'm using screencasting at the same time with two clients that use GHCJS, and one of which is also trying to use the camera. Maybe that's too much for one laptop, but okay. Yeah, sorry. Yeah, it's starting to heat up. Okay, now you can see here the server has actually some debug information like which client sends which actions and so on and so forth. So yeah, hopefully you would be actually able to run this. For some reason I cannot. I'm not sure which of the processes is actually killing the laptop. But yeah, I have like quite a few instances of GHC. Anik, yeah?
Could you talk a little bit about how you first integrated all these libraries and got them working end to end, like what order you did it and stuff like that?
Okay, so let me think. So I've been working with building small games with other technologies in Haskell. Like you probably know the Gloss library, which is like for painless 2D, which is quite limiting, but it is useful for demonstrating simple applications in functional programming, especially to students. Since I teach at the university, it's a useful thing. Another one is Code World. Maybe you've heard of that. And so a few years back, I made a game, a client-server game, which used that to play snakes. So the architecture is basically from there, except they too used WebSockets to communicate, except the client and the server were both using GHCJS, or GHC Haskell and not GHCJS. Now, at another point in time, I was experimenting with virtual reality, and I found out this A-frame, and I played out with Miso and how they integrated, and yeah. But the problem with virtual reality, so it worked. The problem was that, well, for virtual reality, you have to have this virtual reality glasses, or at least Google Cardboard, and it was like fun for maybe a few days, and then it's not fun. With augmented reality, it's as you can see, it still has some, I think, obstacles. But I find augmented reality a little bit more promising. So yeah, so the next step was just combine those and add augmented reality, which is just a camera and a marker. That's not really much change. So I think that like in the near future, augmented reality might actually take off in some form. I'm not so sure about virtual reality, apart from like games that some people like to play. But yeah, and so I think that playing around with these technologies is, although you can clearly see that this is like the very beginning of this, I think in the near future, it might actually take off, and it would be nice if Haskell could actually support some of these things. Another thing that I want to maybe talk about is that the architecture of this it does not actually depend in any way on JavaScript. So of course or HTML for that matter. So for Reflex DOM, which is the other library that Miso for front end in Haskell, there is actually work that makes it possible to cross-compile these front-end applications written in Haskell to build for iOS and Android devices natively. So instead of HTML, they use the UI something for iOS and for Android. Well, some other layout that is used on those things. So and there is, I know there is some work being done on Miso native. So in theory, again, in some future, not that distance, I hope, you could apply the same thing to not run this in the browser, but actually to build a application that runs faster, doesn't use JavaScript, but is essentially also like an augmented reality application that you can install on your phone and go with it. So I think that might be very interesting to do in a few years, maybe. Yeah. Okay. Any more questions? Oh, HTTPS is necessary to use on this thing, on the iPhone, because it will not allow you to access your camera from a browser if you're not over HTTPS. Yeah. Okay.